Hello, I'm Dan Smits, and today I will be discussing the Ghost vulnerability. The goal of this project was to gain a better understanding of an advanced heap-based buffer overflow technique capable of achieving a remote shell. I selected the Ghost vulnerability because it was a well-documented exploit found in recent Linux distributions that has been demonstrated creating a remote shell. Today, I will discuss the underlying vulnerability within the glibc library. The NSS hostname digits.dots function found in the digits.dots.c file, how the exploitation of the vulnerability was achieved for a remote shell, and an understanding of how the vulnerability was patched in the glibc library. What is the Ghost vulnerability, and why is it called Ghost? The vulnerability gets its name from the getHostByName function. The function converts host names into IP addresses, and the vulnerability occurs when IPv4 addresses are provided to the function. This vulnerability is capable of bypassing any built-in protections such as NXBit, ASLR, and PIE. Recent versions of distros such as CentOS, Debian, RHEL, and Ubuntu are vulnerable, but most have been patched in security updates. The root cause of this vulnerability is the absence of the alias pointer from the size needed calculation for buffer size. This buffer is ultimately used for hostname, which is then used in the string copy function, allowing an exploit to overflow the buffer by 4 bytes on a 32-bit system and 8 bytes on a 64-bit system. I have also noted some of the data integrity checks for the user-supplied IPv4 addresses, which I will review in the next slide. The initial overflow must only be composed of digits, which have to be unsigned integers, and dots due to the integrity checking noted on the last slide. Direct injection of hex addresses is not possible because X cannot be supplied to the function. The data has to pass parsing by the inet-aton function. A sample payload is provided in Python. Some limitations of this exploit are only vulnerable in glibc 2.2 through 2.17. IPv4 addresses are becoming obsolete with the advent of IPv6, which is processed by getAddr-info. This function is also capable of processing IPv4 addresses and is not vulnerable to this exploit. The remote exploit is difficult due to the need for forward-confirmed reverse DNS checks, which are pre-validated in other applications. In my demo, I had to add the IP address of my attack machine to the etc host file of my target machine in order to pull off the exploit within a local network. There are several published ways to check for the exploit, mostly involving the checking of the version of glibc on the machine. The version of glibc will not be a definitive indicator of vulnerability due to the backpatching of earlier glibc versions by Linux distros. Red Hat, for example, patches earlier versions of glibc in security updates to avoid forcing customers into larger system updates. The ghost.c file provided by Qualys is a much better indicator because it creates a canary object to test the actual vulnerability on the system using the getHostByName function. Here are some smaller examples of the exploit using the clockdiff and procmail applications commonly installed on Linux systems. These samples could be used for denial of service or potentially further exploited for shellcode injection. Procmail has root privileges to the system and could be used for privilege escalation. For the remote exploit of the EXIM mail server to work, some initial requirements must be met. The system must have an unpatched version of glibc 2.6 to 2.17. This exploit depends on associated versions containing fd next size, a member of the malloc chunk structure, to remotely obtain the address of EXIM's SMTP command buffer in the heap. EXIM server version 4.77, which contains a 16 kilobyte SMTP command buffer to reliably set up the heap. The Helo verify host flag to be enabled for extra security checks on the Helo and EHLO SMTP commands. This flag is turned off by default in EXIM server. Debian 7.7 Wheezy contains all these requirements, with the exception of enabling the Helo verify host flag by default. In the first part of this attack, the buffer is overflowed by only 3 bytes to corrupt the first 3 bytes of memory next to the getHost byname buffer. Corrupting this area allows the malloc limit to be artificially enlarged to EXIM's current block of memory managed by EXIM's internal memory allocator. Next, we overwrite the current block of EXIM's memory in the store block structure to overwrite the next field. With the current field overwritten, we are able to write to any location since we control the pointer to the next block of memory returned by EXIM's allocator, the hijack next pointer, and data allocated with a null terminated string, the argument of an SMTP command we sent to EXIM. With control of the next pointer and newly allocated chunk of memory, we can use the pointer to EXIM's runtime configuration, which is cached in the heap memory. This pointer will allow us to overwrite EXIM's ACL list and execute a command using a run function string function in the code. One detail omitted from the overview of this exploit is how we reliably get the address of the pointer to EXIM's runtime configuration on the heap. This is done when the artificially enlarged chunk of memory overlaps where EXIM saves the 503 error message. Overwriting this area puts the pointer address in the error message. We then use an invalid SMTP command sent to the EXIM server, and the heap pointer is included in the output of the error message. Hello, this is a quick demonstration of the Ghost vulnerability using Kali Linux and MetaSploit as my attack machine and Debian Linux 7.7 Wheezy as my target machine running EXIM SMTP server. The MetaSploit module for this attack was published by Quay Security and uses the buffer overflow technique identified in my presentation to launch a remote shell on the server. To launch this attack from my attack machine, once you load MetaSploit, you can load the module created by Quay Security by typing use exploit linux smtp exim underscore. It's going to be get host by name underscore bof. Hit enter. Then to display the options for this module, type show options, and essentially there are really only 2 options here that need set, and that is the IP address of the remote host and the IP address of the sender host. The sender host, of course, is your local machine. So I'll start off by setting the R host, which is on my local network. It's 192.168.1.125. That is the IP address of the server running the EXIM mail SMTP application. Then I'm going to set the sender host address, which is my address, which is coming from me, which is 192.168.1.123. Once those options have been entered, you can confirm they are there by typing show options, and you can see here my remote host address and my sender host address. Before launching the attack, you can run a check command to go out to the machine and determine that it's vulnerable. As you can see there, my Debian server that's running on a virtual machine in the background is vulnerable. And now type exploit to go ahead and deploy the attack. And it's quite quick. Here okay, so right there, command shell 1 opened, and you can see, so really there's no $ or anything showing a remote shell, but if I type who am I can see that now I am on the Debian XM server at 125, and I can traverse to my root directory. I can list contents. Essentially, I have all the privileges of the Debian XM user, which is essentially has root user privileges on this system. So again, I can even show you config here, and there is the IP address of the remote host server. Thank you. The ghost vulnerability is mitigated by the simple addition of alias pointer to the size needed calculation in the digits.c file of version 2.18 of glibc. Today, I have shown how this exploit can be performed both locally and remotely on an unpatched system. A remote shell can be exploited with minimal target system knowledge and no access to user accounts. Although the exploit only allows the initial buffer to be exploited by 4 or 8 bytes, that overflow can be further exploited for complete remote access as demonstrated on the XM mail server. Despite this exploit being patched in 2013, the exploit was produced in 2015, and many systems were still unpatched because when the patch was produced, the full scope of the vulnerability was not realized. Many production systems are still likely unpatched due to sysadmins supporting legacy applications or complacency. The following references were critical to my understanding and execution of the exploit.